Good morning, afternoon. So today is actually the session where we'll be going through the technical architecture of the payment hub and how payment BB implementation is done over it. So just to give you an overview of what you could expect during this session, we'll go through the scope and expected outcomes shortly. Then we'll give you a detailed architecture overview of the payment hub, how which modules are there, and how payment BB has been implemented, and what API stacks are implemented over payment hub to make it functional. Then we'll give you a little bit of an overview of the installation and testing components, which products are used for that, because we won't be going into details of this, because in the upcoming sessions, we'll be having more chats about that. And then finally, we'll come to the summary and have any questions that you may have. So as previously, just to give an overview, who should attend this training? This training is basically targeted towards all those people who would be involved in the implementation of this project. So any technical project managers and decision makers around that, any implementation team leads and engineers, and any of the operations and deployment teams or DevOps teams. So some of the things that we recommend the attendees should have some of the basic skill set. They should have the basic understanding of the Govstack initiative, because that would help understand why the functionalities are being implemented, those that are being implemented. What are the basic requirements for G2P and P2G payments? Then have basic understanding of Kubernetes and deployment of containerized applications, because this is how the entire project has been implemented. And then have some basic understanding of standard terminologies in conjunction with system deployment and payments. So before we proceed, just to give you a roadmap, because we already told you that we have 5 sessions. One session has already been done, where we give an overview of what is Payment Hub and what are the payment building block requirements and how they have been implemented. This session today, we are going to be exploring the technical structure and how payment building block has been implemented over Payment Hub. The upcoming sessions are related to the actual implementation, installation, deployment steps, and what should be the considerations for its implementation. In the 4th session, we'll be talking about how to test the functionalities that have been implemented over Payment Hub. And 5th session would be related to report services and warranties. So in today's session, as we are going to see shortly, I'm going to come over here. This is the scope that we'll be covering. I'll be covering this in another slide. But before we go to the scope, just a note that these are the terminologies that you would be hearing throughout the session. We have Payment Hub and Payment Building Block. So Payment Hub is the candidate solution that has been used to implement the Payment Building Block implementation requirements. So whenever we are referring to Payment Building Block, it refers to all the API stacks and the functionalities that were laid down by the Payments Building Block working group. But when we talk about Payment Hub, it is the actual solution that has been used, and it is the first solution that has been used for the implementation of Payment Building Block. So just as a disclaimer, as we did previously as well, all the features that have been developed for Govstack are now also part of the main deployment, so they're available. Just to give you an overview of the objective of this training, we want to equip you with the understanding of the overall technical architecture of the Payment Hub and the functionalities that it is providing. On top of that, we also want to highlight the specific payment BB services and modules that have been deployed over the rails of Payment Hub, and what APIs have been implemented and are integrated with the system. And then we want to give you sufficient understanding of all the functionalities that are being provided and how they can be utilized over the Payment Hub. At the end of the training, we hope that you would have sufficient understanding of the payment building block functionalities itself and how they have been implemented over the Payment Hub, and how Payment Hub is able to communicate with other building blocks. We'll be touching upon this briefly. Then what is the underlying technical architecture of Payment Hub itself besides the overlay layer of the payment building block. Then we will also be telling you a little bit about all the briefly touching upon all the functionalities of the various modules and how they're used for the working with payment building block as well. We'll be again talking about the API, so you would get some idea of the use cases that are possible through Payment Hub. And then at the very end, we hope that you would get some idea of what are the prerequisites towards setting up the Payment Hub, and which we'll be talking about in detail in the upcoming sessions. All right, just to start, the model that we'll be showing you shortly, the overall architecture model, it is based upon some principles, and some of those principles are specifically related to, for example, data protection and safety. So I'll be showing you the requirements from Govstack as well, where the prerequisites were for setting up a payment building block. So our architecture model coincides with those requirements. So based upon the data protection safety, the model ensures that there is sufficient safety. No unauthorized access could be done to the environment. Each service is within its own container, and there is sufficient privacy for each of the functions. Then to provide functional efficiency, because this is again deployed over containers, and we also have multiple models as well, deployment models as well, which we'll be talking about in the later sessions, which ensure that there is optimal efficiency of the system, and it is high availability as well. And then, of course, the whole concept of reusability and remodeling of various use cases is kept in mind so that it is fairly extensible. It could be used in multiple situations, and it could be enhanced and customized as per requirements. What you see before you right now is the basic technical architecture of the Payment Hub. And this is the model that is used for deploying the entire solution. We'll be talking about this briefly, but what you can see over here at the onset is that this is the entire cluster when it is deployed. Each of these different modules and services are deployed in different containers, and they make up for maximum efficiency. I will just go to this link over here because I want to show. All right, I already have this over here. On my screen, you can see some of the requirements which I was talking about previously, that as per Govstack's written, the building block needed to be autonomous, it needed to be flexible across use cases and sectors, it needed to be interoperable, and it needed to be improved and build upon the functionality that it has already been made upon. And other than that, it also required Open API, REST APIs. It needed to be packaged in a container, and it included to be able to communicate via an information mediator. So these were the basic requirements. And if I am to show you, all of these requirements are met over here. It is communicating via REST APIs. All of these modules are packaged in containers. And then it is communicating via the information mediator building block. All right. So proceeding just to explain how this is all deployed and what it is doing. First of all, as you could see in this diagram also, the entire architecture is divided into various containers. And we will be talking about each of these containers and each of the nodes separately as well. So the main nodes that you could see over here are related to, we have the master node, then we have the ingress controller node, which balances the load traffic and acts as a reverse proxy. We have the worker nodes, in which we have this specific block, which is related to the payment building block functionalities. We have event streaming and transaction orchestrator components, which are also communicating with, we have specific connectors, which we'll be talking about in the upcoming slides as well, and which we talked about in our previous sessions as well. One of the main points of Payment Hub is that it has several connectors, and it can allow integration with other connectors as well, so that the different entities could communicate with each other, with external entities as well. Then there are certain operations components that are there, for example, including a UI. We will be talking about that. And other components such as the RDBMS service, as well as the Elasticsearch services, which ensure that near real-time updates are done for the transactions, and the entire system has the latest information. And lastly, we will also be talking about the components that enable implementation of the system itself, how the test cases for it are designed, and how all of these are packaged into a Circle CI file so that it is deployed properly in one go and very easily. So these are the basic modules that we'll be talking about. All right, just to give you some perspective, in the slides that we'll be sharing, we have descriptions written down for each of these nodes and modules. But for the sake of clarity and for this presentation, what we'll be doing is we'll be focusing on this diagram itself and talking through it. All right. So we start with the master panel. Once this whole cluster of Payment Hub is deployed, all the information related to it, how this cluster is going to be deployed, how the nodes are going to be managed, how they are going to be, the tasks are going to be scheduled into them, what desired state is for each of the nodes, and to ensure that it is highly available, that is managed through this one container where the master node resides. So this master node is anytime any requests are coming in, the traffic is coming in towards the Payment Hub, this node would be responsible for directing it, for scheduling the jobs into setting up the entire jobs in the Payment Hub itself, so that it is always available. Should any node go down, it would be able to pull up another node which is functioning better, so that we also ensure high availability as well. So this container is deployed at the time of deployment. This is the one that is deployed first, and it ensures that the rest of the deployment goes along smoothly. Then we come to the ingress controller, this container which you see over here. This is, again, we'll be talking about this in the next session as well, but this is more like an environment specific. These components are not part of the Helm charts that are included in the Payment Hub deployment, because they are more like environment specific and depend upon the implementer's choice which components they would want to use. However, we have written down the ones that are used in our environment mostly. So we have been using Kong, we have been using Nginx for managing, for load balancing, as well as for reverse proxy purposes. So either of these could be used. They ensure that whenever any transaction comes towards them, they are able to manage the load. They are able to check whether they're coming from an authentic source or not. And then if it is authentic and okay, only then they would allow the transaction or the resource to get entry into the Payment Hub itself. So this is the public facing zone, so to speak. Also, we are showing over here Keycloak in part of this container. Again, as I said initially, that this is more of an implementer's decision. We in our environment have Keycloak, but you could have any other access management system. Any sort of Active Directory could be used, and it could be integrated with the Payment Hub. So that is one of those configurable possibilities that Payment Hub also provides. So this together, this whole container is responsible to manage the traffic, incoming traffic and outgoing traffic, and ensure that no unauthenticated resource gets entry into the system, therefore ensuring that security clause that we talked about earlier. Now, these 4 blocks that you see over here match the requirement where we wanted to know how the Payment Hub is able to communicate with other building blocks in a DPI environment, so to speak. So what you see over here is that, and all the communication is being done through the RESTful APIs, which we'll be talking about shortly as well. Source BB could be any building block, any other building block, any other government entity or ministry, which is sending a transaction or initiating a transaction, which requires information transfer through the payment hub. It sends it to its connection of the information mediator building block, but checks it for where it is headed, routes it accordingly, and then it identifies that this is routed, this has to be routed towards payment building block. So it sends the request ahead to the payment building block, information mediator building block, which then communicates with the payment hub via this ingress controller, a node that we talked about previously. So this part is, again, this is external to payment hub entirely. This is not part of the payment hub deployment we are talking, but we're just showing here to cover the fact that payment hub is open, is interoperable with any other entities as well. So this covers that part. Now, before I come to this particular yellow part, let me just give you an overview that this whole diagram, all the containers that you see over here are the entire payment hub cluster that we are talking about, apart from the ingress controllers. So now this part that you see, the larger part, is basically the payment hub, which is performing the core functions. Excuse me. And in it, they're further divided into separate nodes, so performing specific functions.
So, as Ravi was saying, this was the core bit with all of the main modules, which we'll be going through in more detail. So, the channel connector, which obviously connects out to the inbound channel. So, for example, source building blocks. The identity account mapper, which has been developed to map functional ID to the payment details. The bulk processor, which does the majority of the bulk payment functionality, so batching, etc. The voucher engine, which obviously handles all the voucher related stuff, and bill pay, which is relating to the P2G payment module.
So as David was just telling you, one thing which we want to also highlight over here is that this specific yellow highlighted part is the actual payment building block implementation. Payment building block implementation over the payment hub. So this is the part that you will be interested in, how it has been built over the payment hub. I suppose you've talked about the channel connector, bulk processor, voucher, bill pay, and then we have come to the identity account mapper. This is one of the most important modules that has been designed for the purpose of enabling government to person payments. And this is where all the information for beneficiaries is kept, the financial information for this is where against the functional IDs that have been allotted to the beneficiaries, their financial address information and the way they want to be paid eventually is kept. And this is the block which only has that information, and no other building block has that information. So in essence, this is why the payment building block is responsible for providing that information and ensuring that the data privacy is kept. Now over here, this is not just the modules, but the API stacks of these modules is also kept. We'll be talking about that briefly, but we have both a set of async and synchronized APIs. Mostly they're async APIs. However, some of the APIs like related to voucher redemption, they are synchronized APIs because considering that if some call comes for voucher redemption, a person is not going to stay and wait whether the response is received or not. So we'll be talking about that briefly. Now, what happens is that a transaction has come over here because we have both sync and async APIs. For the synced calls, as soon as the request comes in, that same module responds back to the resource based upon whatever the response is. But if there are some async calls, which are related to payment transactions. Then they are forwarded to the system via these two components that you see over here. We have Kafka and we have ZB Orchestrator. So Kafka is our event streaming component. It ensures that whatever transactions come in that require async updates to the database or have to be waived, it allows all those scheduling and queuing of those transactions. It communicates, as we're going to see ahead as well, it communicates with the entire system with all the other services. And this is where all the updates come in. And it takes inputs from Elasticsearch and sorry, and from the RDBMS as well. We'll be talking about that. And one of the most powerful components that we have for Payment Hub is the ZB Orchestrator. It is the orchestrator where all the BPMN can be configured. We have, as we told you about the upcoming session, in the upcoming session, you would also be able to see how various components could be configured or customized as per the requirements of the implementers. So it allows it could either be taking inputs or from Kafka. It could also be sending in outputs to Kafka. It could also be initiating processes to the other connectors. And in short, making all the transactions happen and all the functions processes happen. So these two are one of the, you could say, the engine behind, the main working engine behind making the Payment Hub process as the main transaction processing engine. Now, we come to this part of transaction processing. Like we talked about initially, and we've talked about in our other session as well, one of the powerful features of Payment Hub is that it has lots of connectors, and the connectors are able to connect the incoming transactions with some external entities. So apart from the various connectors that we have some payment scheme connectors that allows Payment Hub to connect to other payment scheme, for example, module loop services. Then we have specific module loop connectors as well, including its account lookup service, the instant payment systems. Then we have other account management system connectors. For example, if some transaction is trying to, if some source is trying to communicate with the co-banking system of other financial institutions, then it would be through this connector that they can communicate with the external environment. Then, of course, there are Fineract connectors that are present, which allow sources to communicate with the Fineract instances. What you see over here is also in an external environment, totally external environment, is that because of these connectors, you could communicate with the outer world. So if we look at the bigger picture, we see at this one end, at the left end, we have the Govstack, or let's say a government, an e-government system. It can easily communicate with the system at this right end and connect with the consumer side as well, with the public. So this is essentially making the bridge between the government entities and the public entities, therefore ensuring more financial inclusion. Excuse me. So now we see that the incoming transactions have come, the transaction processing has been done because some requests have come. How all of these are being enabled is through this operations node, so to speak. But before we come to that, this is a specific, I've highlighted them separately because this is related to the operations app, the UI that we are providing, and some of the backend services that we're providing for that UI. So we have a sample of operations app UI, which is already deployed in Govstack environment as well as our own environment. Right now we're working on it. It gives several functions. We went through this. If you would be interested in knowing what are the interfaces that it is providing, we have shared the screenshots in a previous training as well, but we would also be able to see. So the operations app lets only the authorized users, again, the authorized users are decided through the Keycloak or any access management system that the government entity has. They could log into the operations app. It's a, excuse me, it's a web interface. They could upload vouchers. They could create vouchers. They could look at the batches of bulk transactions that are already in the system. They could also create batches of transfers, and they could see their final statuses as well. Also, one of the interesting parts is that it provides an interface to look at the account mapper, the identity account mapper module that we talked about, and lets us see what entries are already there, what functional IDs have been assigned to specific program IDs. We'll show you the view of it shortly. Now, the main operations components that, of course, there are other operations as well, but these are the main operations that are helping out our Kafka and ZB orchestrator over here. So we'll be talking about them briefly. So we have the importer RDB MS service and the importer Elasticsearch services. All of these, both of these, they ensure that almost in real time, the information is updated to the specific DB as well as Elasticsearch, so that all the rest of the components would have the latest information whenever required. This ensures that the data is the data fidelity as well, so that at one point every component, every service has the latest data and knows the real status. And they actively communicate with Kafka, and Kafka takes input from the Elasticsearch and sends output to the Elasticsearch, so that they are actively updated as well in the DBMS. What we're going to show you in ahead as well, that for external systems, when they have to communicate directly, they would be communicating via the connectors, directly communicating with the database, and that data is then pulled by the importer services and Kafka is updated. So this way also we are ensuring that data and communication is occurring at maximum optimal efficiency. And lastly, for the operations, which we want to talk about, are these extra capabilities that are there and that are provided in the with the package of deployment package of Helm chart for Payment Hub. So a Payment Hub is able to integrate with Kibana as for generating reports, for also monitoring various transactions. In our very last session, session 5, we'll be talking about Kibana and show samples of some of the reports that could be generated through it and keep track of them. Other than that, there are modules for notifications and message gateway. These are the modules, services that allow Payment Hub to send out notifications to its the sources that are integrated with it and that require notifications via messages or whatever deployed, whatever configured method of communication there is. Now, lastly, we come to this part. This part is actually which is enabling the actual deployment, testing, and updating of this entire infrastructure. So the deployment is actually done through the Helm charts. Now, these Helm charts are actually part of the continuous integration, continuous delivery CI/CD pipeline. There, I'll show you how this is done and how that is done. So we'll talk about that. And all the testing for components and integration testing, the tests are written down in Cucumber. And then again, those tests are part of the CI/CD pipeline. And as soon as they're updated and the CI/CD pipeline is invoked, it carries out the changes. So this is actually an overview of the entire architecture. So when a transaction, let's say, comes in here, it goes through all of these various modules and services as required, and it enables talking to it. All right, I have already talked through these, so I just want to go ahead. Just as I told you before as well, that we have the written down things for all the things that we've talked about over here. And for further references, you could go through these. We are coming to the payment DB implementation modules and the API stacks that we talked about. First off, we will be talking about the G2P cases, specifically the identity account mapper. So as we talked about it previously as well, the account mapper is basically that service which has all the information stored against a token functional ID that has been allotted to any beneficiary. So in the instances, for example, where any government entity wants to start a social welfare program, for example, or wants to disperse salary to its employees, but it does not want to take that hassle of maintaining all their data, financial data as well. This is where our identity account mapper would come into play. So identity account mapper would keep all that information, and what the source building block or a government entity would do is at that allotted time, they're just going to go select the people they want to pay to and send that batch towards payment building block to verify and then initiate payments. So the basic information that is stored in the account mapper is functional ID, which is some sort of a number which is allotted against the registered beneficiary. It also stores the payment modality. What this means over here is that whenever the funds are dispersed to the beneficiary, what is the mode through which they would be receiving the funds? What are the means of getting those funds to them? Most importantly, it saves the financial address of the beneficiary, and this financial address could either be an account number, this could even be a mobile wallet, it could even be an alias, for which if it is an alias, then that call goes out to an account lookup service. In our case, if there is no account lookup service present, then it goes to a Mojo Loop Oracle via the Mojo Loop connectors, right? And then there are various ways, as I told you, that we talked about the various payment modes that are available through which the payments could be made. These are the ones that we're talking about. We have bank accounts so that the beneficiary could get money directly, the transfers funds directly in their bank accounts. They could get it through mobile money. Again, for over here, it is important that we mention the connectors that we have. We already have APIs that match with the GSMA connectors, and through it, it is making it possible to get funds across to the people on their mobile money. So that is there. Then we have vouchers, which could be used as a payment modality, and the beneficiaries could go to specific agents. Then they could ask to redeem their vouchers, which we'll be talking about the vouchers engine part. And then again, they could get it through aliases, because if they do not want to share any information, sensitive information, then an alias is saved in instead of a financial address, and that call goes to the account lookup service via the connectors that are available in the payment hub. We come to the APIs that are there for identity account mapper. Basically, the main APIs is the register beneficiary request and then the register beneficiary response, and the updating beneficiary request and response. So the register beneficiary request, we also talked about in the use case we had in our earlier session. So whenever a registration building block, any government entity has already gathered the information at their end, they can call this API from the payment hub and upload all the data, create a payload of all the beneficiaries to it with all the relevant data fields that we've talked about previously, and send this to payment hub so that it can validate if all the information is correct as per the functional ID is not duplicated, perform some basic validations, and then store all the data in the identity account mapper. And once that has been done, it sends a response, a callback API back to the registration building block, which tells about the cases that have not been successful. So the cases that are successful are already there. They are not communicated, but the ones that have not been able to be registered due to some validation issues are communicated, and the reason for their not being created in the system is also communicated. We will look into it in more detail in the testing strategies session, which would be the 4th session, and see what are the inputs and expected outcomes. And the other API that is related to the identity account mapper is to update any information that would have to be done for a against a specific functional ID. So the registration building block, again, the source building block could initiate a request uh, for updating that information, send in the new value, and payment hub calls back and updates the source building block, whether the information has been updated or not. And the other module we come to is the bulk processor module. So this bulk processor module, as we talked about, it has a lot of functions it is performing. So bulk processor receives, for example, because it is specifically also related to and it is dependent upon some beneficiaries being created beforehand. So we could say that registration beneficiary is a prereq to the bulk processing that could happen. So there needs to be some beneficiaries already registered in the system to which the bulk processor could send the payments to. However, having said that, in future, there could be other ways and means as well. Anyway, so the bulk processor, it receives batches from some source building block, batches which could be targeted towards any of the different DFSPs. They could be targeted for multiple financial institutions. It receives the bulk credit instructions, then it performs certain validations on it, whether the batch is correct or not. If the batch is correct, it, as we talked about in a previous session as well, it sends that the list of all the functional IDs to the identity account mapper to get the financial addresses against each of the functional IDs that have been shared with it. Once it gets those functional IDs, it breaks down the larger batch into sub batches. And then those sub batches are sent out to their relevant, before they could be sent out to their relevant payees, they're actually sent first back to the payer FSP via a connector, via payment scheme connector of Payment Hub to check whether there are sufficient funds before those disbursements could be done. So we'll be looking at the API, specific API that we have for that. Once that check has been done, the sub batches are authorized that yes, all right. The Payment Hub sets instruction to the payer FSP that please dispatch the amount which the payer FSP does via its external payment system. And once it has dispersed the funds, it gives a callback API to let the Payment Hub know of the status of the payments. So essentially, the bulk processor is receiving the batches. It is breaking it down into sub batches. It is validating that there are enough funds in the payer FSP to honor that transactions, and then it is also getting updated from the payer FSP that the transactions have been done and their statuses are showed either back to the source building block or on the operations app as well, which is an option that is being given by the Payment Hub. So some of the APIs that we were talking about. So the bulk payment API, this API is actually used by both the source building block and then by the Payment Hub as well to initiate the bulk transfer. So when a source building block calls this API, what it does not have any financial information in it. It simply hands in the functional IDs and asks the Payment Hub to initiate transactions against them. So we'll be looking at the inputs and outputs of it in the upcoming sessions. This is API's function is to initiate the bulk transfer. Once the bulk transfer has been done, not considering all the other sub functions that have been done in between, the payer FSP sends back a bulk payment status push. It lets the Payment Hub know, and then the Payment Hub sends that API back to the status push back to the source building block to let it know what is the status of the transactions that have been pushed into the sub batches. So we have this get authorization API. This API is actually the one that is used by the Payment Hub to ask the payer FSP if it has sufficient funds to honor the transactions that have been asked in the bulk payment. And this is the response, get authorization responses, because all of these APIs that you see over here are asynchronous APIs. That's why they are first sent ahead and then the callbacks are sent. And over here, one thing which I would like to mention again is that because you see, these are the asynchronous APIs, what would be happening is if we come back just to quickly give you an idea of how the transaction is actually working. So the transaction, let's say, came for a bulk payment. It came via source BB through the IMBB. It went into the ingress controllers. It got instructions from the master control panel that, yes, this is okay. You fire up the resources at the worker nodes. If the transaction is coming from an authentic source, it is allowed to go inside the payment hub. Bulk processor gets this transaction, it sends it to the identity account mapper to verify. If it's fine, then it sends to the connector. But when it sends to the connector, it goes through the Kafka because it is an async payment transaction, and Kafka publishes it and then listens to the response that would come through the connectors. So just to give you some perspective of how Kafka is involved in how the orchestration is being done. Yeah. Just a minute. So the other, because when this API comes back for the bulk payment status push, it does not give you the complete details. It just tells you what is the status of the transactions that have been done. It does not give you the other details. But if you want to get more details of the batch, what is happening, what are the details, then you call this API. And let's say the status push, that's callback API, does not come back from the payer FSP, or the payment hub, the link between payment hub and the source building block is lost. Then there is also provision for payment status check request, through which the source building block can send to get specific updates on what is the status of the transactions. We have these account lookup APIs and bulk account lookup APIs. These are actually the internal APIs of the payment hub, and they're not directly related to the external entities. These are the services that are by default being provided by the bulk processor to check whether the accounts are fine or not. Now we come to the voucher engine. Excuse me. So the voucher engine is also providing multiple functionalities over here. It is the first part is it's a prerequisite before the vouchers could actually be issued or created or issued. The source building block or the government entity which is trying to issue the vouchers has to ensure that there are sufficient provisioning of funds in both the payer FSP as well as it is also noted to the payment hub, so that only that amount of corresponding to that amount of vouchers could be created. So provisioning process is a prerequisite to creation of vouchers and ultimate issuance. The next voucher engine plays an important role in this. Why? Because this is where it will check once the amount has been provisioned. This is where it will check against the incoming request. The first part in the voucher creation life cycle, or how the vouchers are being used, is the issuance of vouchers, which is what we could say the part that comes after voucher creation. Voucher creation will be again going through the API, so you would get a better understanding of what we are talking about. The first part is this is the process in which the vouchers are created and then issued to certain specific beneficiaries. And for example, this would be the process which would ensure that against the functional in the identity account mapper, against the functional IDs of the beneficiaries, their modality is written as vouchers. Then voucher engine also, excuse me, also helps in the activation process. This activation process again is done. We have APIs for that. What happens is when at the time of voucher issuance, the vouchers cannot be redeemed meaning they could not be used at all because they are by default in an inactive state. So to make them active, a specific call for activation API has to be done. Once the vouchers are activated, they could be used by the beneficiaries. And finally, voucher engine also helps in redeeming the vouchers so that beneficiaries could benefit from that. Some of the things that have to be kept in mind for the voucher, the whole voucher life cycle is that, as we talked about, it is very important that the funds are provisioned, and only those vouchers would be created for which the fund has been provisioned. So that has to be matched. And also, it is also important, one of the another points to notice that vouchers, once being redeemed, will only be redeemed for the same amount. They cannot be partially redeemed. They could not be, they could be redeemed only for that amount for which they have been created. So this is some of the things that have to be kept in mind. Also, when we are talking about voucher creation, one more thing that has to be kept in mind is that the voucher creation activity itself works on all or none concept. So once the amount has been provisioned in the banks, if the file that is, or the API which is carrying the list of all the vouchers has any issues with the data that in its payload, any data is not correct, then the entire batch of voucher is rejected by the system. So in a single batch, all data has to be correct or none of the vouchers are issued. So that has to be kept in mind. And finally, which I told you about, that the voucher could only be redeemed for the same amount for which they have been created. Now, these are the APIs that we have for voucher engine. We have voucher pre-activation API. This is basically the voucher create APIs. In other words, this API once called will create the vouchers along specific functional IDs. So the functional IDs in this call is optional. However, it is recommended that the functional IDs are also sent at this time because that would issue the vouchers to the specific beneficiaries. But one thing which is important to note at this point is that any of the vouchers issued as a result of this, they are not in an active state. They have to be activated later on. So voucher pre-activation is the voucher creation API. Then we have create vouchers response API. Once the vouchers have been created, this response is sent to it's a callback API, which is sent to the source building block, telling about whether the voucher creation activities was successful or it was not. And if in case it was not, then the reason for that is also shared. Then we have voucher activation API, which would set the status of the vouchers to active. In the API, excuse me, the API collection that we have, you would be able to see that the status in the database is set to active once this API is called. And in response to this activate API, we have the voucher activate response API, which tells the requesting building block what is the status of activation activity. Then we also have an API which can cancel the vouchers that have been created. So in the life cycle of a voucher, we could see that it's at inactive state, then it is activated. Then once it's activated, it could have a few more possible states. It could be either be canceled, it could either be redeemed, or it could either have expired. So there are various life cycle moments in the voucher. Another API for the voucher cancellation request. Again, we have the voucher cancellation response. And then we have voucher redemption API. This is called, let's say, if a beneficiary goes to some agent, for example, then the agent via its FSP can initiate this request and redeem the voucher for that beneficiary. We also have a voucher status API. So for example, if we are not sure what is the status of the voucher, whether it can be redeemed or not, this API can be called and it could respond in either of these 6 statuses. As we told you, that it could either be inactive, it could be active, it could have been canceled, it could have expired. Utilized, it means it was redeemed, or it could be suspended. So these are the API collection that we have for the voucher engine. Next, we come to the P2G bill pay module. Again, the bill pay module works on the premise that one of the things that is important for the bill pay module is that it is agnostic to the type of biller it is working towards. So it could either be an existing single individual biller, it could either be an aggregator which is which has onboarded multiple billers, or it could be an existing bill payment system even. It just has one prerequisite, that whoever whoever biller type the payment hub is talking to, that biller is onboarded in its system and has been allotted a certain number which identifies the biller. So this is the prerequisite for the bill pay module to work. So bill pay module allows bill payment either through push payments, which initiates with a bill inquiry and then a push payment, and it also allows a biller to initiate RTP request to pay notifications and request bill payment directly from the customers via their own FSPs. So again, as we said, the powerful thing about this is that it is agnostic to the type of biller. Also, it can work easily in environments or jurisdictions where there are already existing bill payment systems. Some of the services that the bill pay module is offering is the bill inquiry service, which usually comes in handy when we're talking about the push payment, especially for jurisdictions where the invoices are generated either on paper or through even SMS, but a specific bill ID or an invoice number is generated. The next service that it offers is it itself, the payment hub, the payment building block capability of the payment hub is not carrying transactions themselves, the financial transaction themselves, but they're enabling the carrying out of these transactions. So all the information mediation, passing to and fro is being done over the payment hub. So when we say bill payment confirmation, what bill pay module is essentially doing is that it gets the information, the confirmation from a payer FSP that yes, they paid the bill, and lets the biller at the other end know that you should mark this bill as paid in your systems. And it is also has the capability for the biller to send a request to pay notification so that a consumer could pay the bill from their end. Some of the APIs that we have for this is we have the bill inquiry API. The bill inquiry and the bill inquiry biller APIs, they are basically talking about the various stages at which the bill inquiry is run. So the bill inquiry is initiated from a payer FSP, and then the payment hub or the bill pay module identifies which biller this bill inquiry has to go through from its internal system and sends a bill inquiry to that particular biller. We have bill payment and mark bill payment APIs. Again, these APIs are not related to the actual bill payment. These both APIs talk about here in bill payment. The payer FSP lets the bill pay module know that yes, I have paid the bill, and it sends in a reference ID. We'll talk about the inputs over here. It tells that this is the reference ID for which my customer has paid the bill. Tell the biller that they have to mark this bill as paid, and so the payment hub calls this API and tells the biller that you should mark this bill as paid. And finally, we have the biller RTP request API. It's not finally, we have more APIs as well, but this API is actually called by the biller to ask the payment hub to send an RTP request to pay notification to a certain customer. Now, for this API also, when we'll be exploring the APIs further, we'll see that there are multiple options. This RTP request could either be sent directly to the payer FSP address, or it could be done via some proxy or an alias. And in that case, if an alias is being used, then again, we talk about the connectors that come in handy. It could either be the module loop connector, it could be any other existing account lookup service to which the payment hub will communicate and resolve the financial address and send the request to the payer FSP. So this payer RTP request, again, this is the RTP request that is sent by the payment hub towards the payer FSP. To them, the payer RTP response and the biller RTP response, in one, the payer FSP responds back to the payment hub, and payment hub receives that response and responds back to the biller to know whether the request to pay has been accepted or not. Just in case, as previously, if this response is not received by either by the payment hub or let's say by the biller, and they cannot wait anymore, they can initiate a status update request. And this status update is different from the usual status update for transactions because it asks specifically whether the RTP request that the biller sent has been honored or not, or what is the status of it. For it, we have again different statuses. Excuse me. Sorry. The payment could already have been not just accepted, the RTP request could not already have been accepted, but it may have been paid already. And how would we know that it has been paid? It is because once the RTP request has been accepted by the payer, they could have generated at their own end through their external systems the payment and sent back a mark bill pay request to the payment hub. So this is again the entire process that we'll be walking through in the upcoming sessions. It could also return that the request is pending, which means that the payer has still not accepted or rejected the request. The request could have been expired. So for example, if the payer has not accepted the request for quite some time, the request could have been expired and would no longer be viable. The request could have been cancelled, or it could have been rejected by the beneficiary. So the cancel means that the biller itself canceled the request for something, for some reason or other. All right, we come to this part because we briefly wanted to walk through how the transaction orchestration is done and what role specifically Kafka and ZB play in the implementation of transactions. But before we go to that, we wanted to again briefly touch upon the connectors because they are the powerful feature of Payment Hub. David, please, would you be?
Yes, certainly. So as we say, all the functionality of Payment Hub, the orchestration sits in the middle, but the connectors are what protect, but also ensure that the schemes and the account management systems all connect correctly and talk about it. And I guess that we just wanted to call out what the different types of connector are. So you've got payment schema connectors, which obviously connect to things such as module loop if you're going off to a payment switch, etc. You've got more account management connectors, which would be used if you're connecting direct into a core banking system such as Fineract or other core banking systems that are out there. There's the possibility for fraud detection connectors. These aren't really used in the Govstack implementation, but are a feature from Payment Hub because it supports other different models. So you could connect out to things like Tazama or other fraud detection systems. And then what we call the channel connectors are the things that talk back more towards the programs or the things that are driving the transactions in and out of Payment Hub. So effectively for Govstack, you can consider it to be almost like a branch front end application in the way it's connecting in and it's sending those transactions in or out. So I think it's important just to keep that sort of wheel around the outside of Payment Hub in mind. The reason we've done this in this method is that it makes it much more easier if you want to connect to something that hasn't been thought of at this present point in time, or a new standard comes out or whatever. All you actually need to do is create one of these connector modules, which are quite small, to be able to work with Payment Hub and make it, work with different schemes. Okie doke. On to the next slide.
All right. So we've talked about connectors, but what you can see over here as well is the process orchestration. So we just wanted to give it its due importance as well. One of the other important part of the payment hub itself is its ability to orchestrate the flows and to ensure that they are being done in real time, and to ensure that the data that is being shared, the information that is being shared is uh, a fiddle, it's proper, it's not lost or something. So Kafka and ZB orchestrators are the two main components that are working over here. Kafka is the main event streaming engine that is being used. It provides all the capabilities of excuse me. It provides all the capabilities of queue management. It ensures that all the transactions, when they come in, they are queued in properly. It provides the pub/sub capabilities, and it communicates with all the other components that require async communications related to payment systems. And then we have ZB Orchestrator. This is again one of the other more powerful engine that we talk about. We will be looking at the BPMNs in the upcoming sessions as well. And it allows to quickly reconfigure, customize the processes as and when required. So together they ensure that not only are the transactions happening properly, but the system could also be enhanced, it could be scalable, it could be extensible, and it could cover various use cases as well. So one of the requirements when this whole project started was that the system would be adaptable to upcoming or further new use cases as well. So together, because of these capabilities that we have from Kafka and ZB, we can ensure that new use cases could be handled. New processes could be put in and could be integrated within the system. So as we can see over here, Kafka provides streaming capabilities with the payment hub. It acts as a central hub for integrating data from various sources. As I already told you, it is communicating with all the other components. For example, it's communicating with all the operations, Elasticsearch and the RDBMS as well. So it also acts as a buffer and intermediate layer for data movement in ETL processes, because let's say if the database wants to update it, or it wants to get an updated information from database, so they can directly communicate. It is also has the updated information sends to for the monitoring purposes. So if Kibana, it is taking feed from the Elasticsearch, Kafka would be able to update Elasticsearch as well with the latest information, so that when you go for monitoring, you have the latest information as well. So what I was actually trying to show over here was, because we've been talking about that, so this Kafka is the main brains right now behind it. And for all of the async communication, you can see it is coming from either from the payment building block implementation, it is also coming from the operations app, it is incoming, outgoing information. So it's basically talking to all the other modules and services within the implementation. And whatever information, whatever transactions that are payment related, especially for asynchronous transaction, and they are asynchronously updating the database, that is happening through Kafka. Then we talk about briefly, again, we talk about the ZB orchestrator. So, and again, this is one of the other important factors for Payment Hub and for utilizing it as the candidate solution for Payments Building Block is also because it is an open source solution. And so other solutions that have been implemented are also open source, and therefore, because the community has been working on it and it's developing it better. So ZB orchestrator is also an open source microservice orchestration engine. And it is, as we told you about previously also, it's good for scalability and for extensibility as well. So we could handle new use cases also effectively. We could customize them as per requirements. And again, ZB is also communicating with all the operations app, and as and when required triggers events, whether the information has to go to any of the connectors, whether it has to go to any of the operations app, whether it has to initiate any process, ZB orchestration through ZB orchestrator, that could be made possible. You just have to define that in the BPMNs, and that would be able to be done. This is just a a general transaction handling node that we wanted to bring over here. So within the same tenant and payment hub boundary, components communicate with each other through orchestrator. As I told you that this is at the center of the main communications. And then across tenants and outside of the payment hub boundaries, components communicate by directly consuming the external APIs. Now, what is happening again? So for example, if some request comes in through any of these vouchers or modules, the BPMN would invoke any of these connectors and they'll be directly communicating through the connectors. This also coincides with the channel connector that you see over here. So for all the external communications, they could happen via the connector APIs, external APIs. And just to give you more idea of when we see all these blocks in this diagram, all of these are actually taken as modules or services. That's what we're referring to them as well, so that you can better understand. All right. We've talked about connectors above as well. So we just wanted to bring that to a close about this. So connectors can receive instructions from, as we've already told you about, we talked about connectors can receive instructions from ZB, they can receive instructions from Kafka or any other modules as required, and they are able to communicate with external entities. So we'll just go ahead. And these are basically, again, not just providing the flexibility, but they are also providing the interoperability that is an essential to the concept of a payment building block. And because they're connectors for various different services, external services, as David was also just talking to you about, they bring in the adaptability of the system as well. So irrespective of different protocols or the standards, the connectors could be used to translate from one standard to another and make communication across different entities possible. All right. We've already talked about the connectors above, so I will just, David just walked you through all the different connectors. So if there's any thing you want to add further to it, David, otherwise I could move over.
No, I think move on. I think we covered that previously.
Yeah. All right. So this just wanted to portray briefly, let's say if a transaction comes in, what would be the path that it would take? Try to walk through that previously as well, but just to give a quickly, if any instruction, we are talking about, let's say some source building block sends in an instruction, let's say wants to initiate a bulk payment, so to speak. It starts here. I am not sure if my cursor, yeah. It starts here from the source building block, it passes through the IMBB, it goes to the ingress controllers where they are checked whether it is coming from an authentic source, whether it is allowed to enter, whether there's sufficient load available. The main control panel lets the ingress controllers and everyone know which nodes to fire up and where to send the request. The request then enters the payment hub. It goes to its specific module, like we talked about. If it's the bulk processing, if it's batch information, then the request goes to the bulk processor, which communicates directly with the identity account mapper. They talk to and fro. Then they decide that yes, they want to know whether the payer FSP has sufficient funds. It sends via the channel connector. It information goes to the payer FSP, and then in the Kafka, it stays there and listens to the whether it has received the response or not. All the meanwhile, the Kafka is also communicating with the operations app. Interesting thing to note over here is that we are talking about an instruction starting from a source PB, maybe via the APIs, but this is also possible through the operations app that we now have. It could also be done that an authorized user has logged in via the key cloak into the operations app, and the operations app is the one which has initiated all of these processes. So what we are trying to show over here is, even though all of these services and modules are set up separately so as not to consume each other's resources, but they can easily communicate with each other, either through ZB, either directly as and when required. They can consume external APIs and make things happen. Finally, we come to the last part where this is what we'll be talking about, these three components that are standing here very quietly. They are one of the most important components because they would enable the actual deployment and installation of the system. So we'll be just touching upon them briefly. What we want to tell you about is that the actual deployment is being done through the Helm charts. And it is because it makes it very easy. Once they have been deployed, they have all the various different components that can be installed, except for this, which these ingress controllers, these are not part of our Helm deploy. We'll be showing you the things that are deployed. And then we are using Cucumber for creating out all the test plans and test strategies. We have in the upcoming session, you will see the test plans that have been deployed and how what basis they are made on and what are the results for it, because it makes it easier. And finally, we have a very good CI/CD pipeline. We are using Circle CI for that. What it essentially does, it packages everything into one big package in one file, and then it uses it to deploy not just the instance. It lets us to configure and customize the files. It also lets us to test as and when new patches or updates come in. So let me just take you over here to give you some perspective. In fact, I have it over here. I'll open up the screen. We'll be talking about this file in the upcoming sessions also, but just to give you some idea, this is a Circle CI file that you over here see. This is for our basic template for deployment. And over here, it has everything that we're talking about. For example, we have Keycloak and Kibana visualization and everything. But this is the Helm chart that we're talking about. Excuse me. So let's say for in the Helm chart, we have various instances. Once we start to deploy it, we have all of these things. Let's us talk about the Payment Hub Enterprise Engine. You can see all of these modules, services that are going to be deployed. Is my screen visible? I'll try to.
Yeah, it's visible.
So, yeah. So when we run the Helm chart for Payment Hub Engine, all of these components are deployed. We can see various connectors that we talked about. We have connector for bill pay, we have connector for bulk, we have connector for channels, we have GSMA connectors for mock payments. I'll show you. We have for bulk payments, gateways, operations app that we are talking about, operations web, the importer, Elasticsearch, RDB, MS services. And for each of these things, components that are deployed, we have other files within them. We have their templates, we have these values YAML files, which we could customize and configure. And we'll be talking about that in the upcoming sessions as well. But in a nutshell, if we just wanted to see how the Helm chart works and how it makes deployment easy, this is how it is. We just run the Circle CI file in our pipeline. It deploys this Helm chart, and that Helm chart in its turn deploys all of these components and connectors so that we can have this giant payment hub at our end. So at the end of it, this is what we've covered so far. In this session, we talked about the principles in which this whole architecture was based upon and what derived it. So we also tried to match it with the requirements initially set down by the not just the working group, but also standard requirements that are there for creating a building block and to ensure that it can be utilized in any of these situations. We talked about the basic technical deployment architecture, what functions are performed by the payment hub generally, as in when we talked about the orchestration engines and the operations app, but also the functionalities that are provided by the specific payment building block modules. We also talked briefly about the APIs that are available for each of these payment building block modules. And then we, in the end, towards the end, we talked about the components that are used for the installation and setup of the system, and on which we'll be talking about more in details in the upcoming sessions. Before we round this up, just to give you an idea, we have gone through the first session, which happened day before yesterday. Today's session was a technical structure. The upcoming session is going to be about implementation, deployment of Payment Hub. We'll be talking about the various deployment models that you could have for Payment Hub. There are a few, 2 to 3, and the one that we give by default, we'll be talking about that. What would be the prerequisite requirements in terms of the infrastructure as well as the skill set of the personnel who would be deploying that. And then we'll have a walkthrough of the deployment instructions. Possibly we'll go through in detail into the files that I just showed you, and we could see how fun it could be to actually configure, and how one file is the unfolding the magic behind being able to deploy that. And we'll talk about what parameters could be configured or customized as and when required. And luckily we're at the end, so we'll take questions.